origin is out as well. So, see if you can find the intercepts and the symmetry for x squared plus y squared equals 9. Alright, our intercepts. We plug in 0 for y. You get x squared equals 9. You can factor. You can quadratic formula, or on this one, since there is no middle term, you can unsquare 9. No, you do not only get 3, you get negative 3. So 3, 0 is an ordered pair, and negative 3, 0 is an ordered pair. Put in 0 for x. When you do that, unsquare 9, and you get 3 for y and negative 3 for y. Why are we getting these same intercepts? It's a circle. X squared and y squared. Remember, we did that at the end of our chapter 1, and we found out that those were circles. All right, so there are intercepts. So to test for symmetry, we put in negative y. A negative y squared is a positive y squared. So yay, it works. So x-axis is a yay. We put in negative x to test for y-axis. When you square negative x, you get x squared. So it is also the exact same. Yay, y-axis. When you put in a negative x and a negative y, what are you testing for? Origin symmetry. You square that negative x, you square that negative y, they both become positive, and it's the exact same thing you started with, so origin is also a key. Notice all 3 were it. Here's a trick for you. It's either x-axis by itself, y-axis by itself, origin by itself, or it's all 3. It won't just be these 2 and not origin. It won't just be these 2 and not x-axis. It will be either one type of symmetry or all 3 types of symmetry. So that is just a little hint of something extra. All right, so let's try this one. It does have absolute value bars on the x, so it might be a little bit trickier to try, but we can do it. So to find the intercepts, we plug in 0 for y, and we get 4, and what else do you get? The absolute value of something is also 4, besides 4. Negative 4, yay, go you, whoop whoop. All right, so now we put in 0 for x. So you get y plus 4 equals 0. So y equals negative 4. So 0, negative 4. All right, kids, let's do this magic. We put in negative y. If we multiply by a negative, we get y minus 4 equals negative absolute value of x. Not the same. So no x-axis. We put in negative x. What's the absolute value of a negative x? A positive x. So yay, y-axis is a taker. We got no on x, yes on y. Based on what I just told you, what would you assume for origin? No, but we're going to check to make sure. We got negative y plus 4 equals the absolute value of negative x. The absolute value of negative x becomes just x. Then negative y plus 4. We tried to simplify before, and we realized to change the sign of the negative 4 as well as the sign in front of the absolute value. So it does not work like we had assumed. Yay, go you. All right, the next part of the chapter, so the second session, is dealing with domain and range. It's also dealing with adding functions together, multiplying functions, dividing them, stuff like that. It's a lot of what we did in World of Functions. So hopefully this will be a review for you. If it's not, make it. All right, so determine if the relation is a function, then for each function state the domain and range. We learned in World of Functions that in order to be a function, your x value cannot repeat itself and have a different y output. So here we got 2, -3, 4, and 2. Uh-oh, I said 2 twice. This one is 2, 6. This one is 2, 10. That means they have different y values for the same x value. So I'm sorry, it is not a relation. If it is not a relation, you don't have to do the rest of the stuff. Don't you worry. Most of them are relations. All right. Okay. So this one, we got -2, -2, 0, 3. Is that a function? No, it is not. So why would Ms. Albers put 2 problems on here that weren't functions? Well, I screwed up. Sorry. So if they were functions and we had to state the domain, your domain are your x values and your range are your y values. So I would simply just say my domain is -2, 0, and 3. My range is 4, 6, 3, and 7. So that's how you state the domain and range if it is a function. Alright, so we did a lot of this jazz. F of 0, F of 1, F of -1, F of -x, negative F of x, F of x plus 1, F of 2x, F of x plus h. What? We did a ton of this in World of Functions, and what it's asking you to do is plug this value in the parentheses in for x. So here we have our problem of 3x squared plus 2x minus 4. So what we're going to do is plug in whatever value they have inside the parentheses there. So we're going to go 3 times 0 squared plus 2 times 0 minus 4. And you're going to get an answer. And that answer is -4. Plug in 1. So 3 times 1 squared plus 2 times 1 minus 4. See what you get. You get 1. Yay, go you. Plug in -1. You get -3. Yay, go you. Plug in -x. So that's kind of what we were doing just a second ago, except for it's not asking for x-axis symmetry, or y-axis in this case, since you're plugging in -x. So we put in a -x, and then we're going to simplify. So what is -x squared? Positive x. So you have 3x squared. What is 2 times -x? -2x minus 4. That one, you do not get an actual numerical value. You get an expression. So watch that. This one has a little negative symbol out in front. As negative and then f of x. What does it want us to do? It wants you to plug negative, take the whole function and multiply it by a -1. So if I multiply it by a -1, I get -3x squared minus 2x plus 4. So basically all your signs changed. Here we got f of x plus 1. So everywhere I see an x, I got to plug in x plus 1. So I got 3 times x plus 1 squared plus 2 times x plus 1 minus 4. Are you done? No, you are not. You get to multiply this out and distribute the 3, distribute the 2, combine all the like terms. Now when you multiply this out, you do not get x squared plus 1. You have to do an area model. Okay. I am going to multiply it out. I'm not going to show all my work there for multiplying out. If you have a question about that, please come and see me. So for this first part, I would get 3x squared plus 6x plus 3. That's by doing an area model and then distributing the 3. For here, I would get 2x plus 2 minus 4. So if I combine like terms, I got a 3x squared, I have 8x, and I have 1 on the end. So we're going to do the same thing for these last two. We're going to plug in 2x, and we're going to plug in x plus h. So try them on your own. So if I plug in 2x, I have 2x quantity squared plus 2 times 2x minus 4. So right here, I have to square that 2, not just the x, so I get 4x times 4x squared, times 3 is 12x squared plus 4x minus 4, and you're done. Plug in x plus h, it's going to look very similar to the x plus 1. So we have 3 times x plus h squared plus 2 times x plus h minus 4. Area model, distribute your 3, distribute your 2, add like terms. So we get 3x squared plus 6xh plus 3h squared plus 2x plus 2h minus 4. There are no